Hey guys, it's Mrs. Bothers, and I hope everybody is holding up well during this crazy coronavirus quarantine. I guess it's been a while since I've actually gotten some feedback from you guys on what y'all have been doing. So I'll put something on the blog so y'all can share some information with me because I miss hearing from you guys so much. As far as what I've been doing, I know before I was saying I was doing some games with my kids, still been doing that, and they are killing me at apples to apples, which is driving me crazy because I'm super competitive. What else did we do? Oh yeah, I did some string art, which I was really proud of. I thought that was so cute, and it was hard too. And then my daughter Claire and I put together the White House. It's like a 3D puzzle kind of thing. It was kind of fun, but it was actually way harder than I ever thought it would be. So that's some of the stuff I've been up to, that, and then making all these videos and trying to keep up with you guys. By the way, it's a lot more work on your teachers than you would think. So, and by the way, I'm super proud of all of you guys because the majority of you have been keeping up with like all of your assignments or most of your assignments and doing a really good job, which I know is not easy during this time. So thank you. I appreciate all of your hard work. All right, in this video, we're going to go over the Unit 9 study guide that's in your MSG on pages 12 through 14. Okay, so on page 12, number 1 asks for you to explain the difference between the solutions on the equation and the inequality. Well, the main difference there is that the equation, if you solve it, would only have one solution, x equals 25. But if you solve the inequality, the answer would be x is greater than 25. So an inequality would have an infinite solution set. Because if your solution is x is greater than 25, that's every number greater than 25. So that's an infinite number of numbers. So the equation has one solution, the inequality has an infinite number of solutions. Okay, now we're moving on to simplifying expressions, which the biggest issue we tend to have on these is, I guess I don't know if I should say carelessness, but making mistakes with negative numbers. So on the very, let's see, on number 2, what we're going to do first is apply our distributive property. So I'm going to multiply -3 times every value in the parentheses here. And then I'm going to multiply the 5 by each of these values here. Now I could, well, I'll come back to that. I'll show you another way you could also solve it. But if I apply my distributive property, -3 times 5a is -15a. Keep the plus sign. -3 times 2a is -6a. I'm going to put that in parentheses so I can distinguish between the symbols. All right, then keep my plus sign. Then 5 times 3 is 15a, and 5 times a is 5a. All right, now I notice that these are all like terms, so I'm going to add all of their coefficients. It's -15, and actually, look at these carefully. I see -15a and 15a. Those are a zero pair, so those would really cancel out, leaving me with -6a plus 5a. So my answer is going to be -1a or just -a. Now you may have also noticed on this problem that you could have actually worked out what was in the parentheses first and then applied your distributive property. So if I use that method, so I've rewritten the problem here, 5a plus 2a is 7a. All right, and then in the parentheses here, 3a plus a is 4a. And then multiply. So -3 times 7a is -21a, and 5 times 4a is 20a, and -21a plus 20a is still going to give me an answer of -a. All right, problem number 3. Same thing, we're going to simplify by using our distributive property and combining like terms. So the first thing I'm going to do is I'm going to apply my distributive property. But I also see I have a minus sign here, so I'm going to go ahead and change that to adding the opposite. So this minus I'm going to change to adding -2. All right, now I'm going to apply my distributive property, multiply 3 by each value in parentheses. So I have 3 times 5x is 15x, plus, and then 3 times -2 is -6. I'm going to bring down the rest of my problem, and then combine any like terms that I have. All right, in this case, I have 15x plus -15x. Well, those are opposites. That makes a zero pair, so those cancel out. I have 70 plus -6, and that's going to give me 64. So my solution on 3 is 64. Okay, problem number 4 is solving a two-step equation. So the first step I'm going to apply is I'm going to get rid of the number that's farthest from the variable. In this case, that's a 10. So I'm going to subtract 10 on both sides of the equation. That leaves me with 2x equals 70. All right, now I'm going to divide both sides by 2. And I get x equals, and 70 divided by 2 is 35. Remember to always substitute your answer back in to check it. So I'm going to put my check over here. So I have 2 times 35 plus 10 equals 80. If I work that out, that's 70 plus 10 equals 80. That's true. So I know that this answer right here is correct. All right, problem number 5. Again, we're solving for x. So the value farthest from the x is the 5. So I'm going to subtract 5 on both sides of the equation. That leaves me with negative 6x equals, and then negative 19 minus 5 is the same as negative 19 plus negative 5. So negative 19 plus negative 5 is negative 24. All right, now I'm going to divide both sides by negative 6. So my solution is x equals, and this is 4. All right, check it by substituting your answer back in. So I have negative 6 times 4 plus 5 equals negative 19. When I work that out, negative 6 times 4 is negative 24, plus 5 does equal negative 19. So I know x is 4 is correct. All right, number 6. We're solving for the inequality for the x. All right, so we're going to solve this the same way we would the equation. So first thing I'm going to do is I'm going to get rid of the 25. So subtract 25 on both sides. That leaves me with x divided by 5 is greater than or equal to, this is 2. Okay, now I'm going to multiply both sides by 5. And I get x is greater than or equal to 10. All right, I'm going to check that by substituting a value in there that would work. Let's say we use 11. Okay, if I use 11 to check my answer, in fact, I'm going to use a different number other than 11, and that's just because if I use 11, it gives me a decimal, which is just a little bit harder. So I'm just going to use a number divisible by 5, so I'm going to use 15. All right, so because 15 would work here. So 15 divided by 5 plus 25 is greater than or equal to 27. All right, 15 divided by 5 is 3. 3 plus 25 is 28, and 28 is greater than or equal to 27. So my solution is x is greater than or equal to 10. Then I want to make sure you understand how to graph it. So remember, when you graph it on your number line, you've got to have obviously 10 on your number line. Since it's greater than or equal to, we're going to put a closed circle on 10, and greater than means it could be any value to the right because the numbers are getting greater to the right. So closed circle, shade right. All right, problem number 7. All right, so on this one, actually, the first thing I notice on this one, keep this in mind, is I'm multiplying x by a negative in this. So I know I'm going to end up flipping the symbol or reversing the symbol. But I'm going to add 5 on both sides. That gives me negative 4x is less than 60. Now I'm going to divide by negative 4. And I have x, and 60 divided by negative 4 is negative 15. Since I divided both sides by a negative, I have to reverse the symbol, so it's going to become greater than negative 15. All right, so now to check it, I'm going to choose a value that would be true here. Well, 0 is greater than negative 15, so 0 is what I'm going to use. But again, you could use any value that is greater than negative 15. All right, so negative 4 times 0 minus 5 is less than 55. Well, negative 4 times 0 is 0 minus 5. So that gives me negative 5 is less than 55. That's true. So this right here is correct. And then when you go to graph it on the number line, since x is greater than negative 15, it's not greater than or equal to. We're not including negative 15 as part of our solution. So we have an open circle on negative 15. And since it's greater, we shade to the right. So on problem number 8, I'm going to ask us to find the perimeter. Well, we know the perimeter is the distance all the way around a shape. But notice we don't have all of the side lengths. This side length and this side length is not given to us. So we've got to figure out what those missing side lengths are. Well, I notice on this side right here, okay, I have 9 here, 6 here. So this side here has to be 3 because 3 plus 6 is 9. This missing side length here, I would get that by subtracting this side minus the side here. So this missing side length is going to be A plus 3. Okay, it's not drawn to scale, so don't worry about that. All right, and then to find the perimeter, I'm just going to add up the all the side lengths on that shape. So I've written out all the side lengths here, and then I'm going to combine my like terms to add them together. 4A plus A is 5A, plus 3A is going to give me 8A. And then all the constants, 3 plus 6 is 9, plus 3 is 12, plus 3 is 15, plus 9 is 24. So my perimeter is 8A plus 24. All right, then when we find the area, again, this is just taking what we did in Unit 5 with composite area and meshing this in with what we've done in this unit with combining like terms with negatives. And this one doesn't even involve negatives. So to find the area, what we would need to do is split this up into 2 different shapes. Okay, so I'm going to look at this rectangle at the top and this rectangle here at the bottom. All right, for the rectangle at the top, we know area is length times width. So I have 6 times 4A plus 3. All right, and then on the bottom, I have 3 times 3A. Okay, and then when we solve these, this is going to give me 24A plus 18, and this is going to give me 9A. So I have 24A plus 18 plus 9A. When I combine my like terms, I get 33A plus 18, and that would be in, we'll say, square units. All right, problem number 10. Let's see, we have 8 less than the product of a number and 3 is 22. So write it as an equation. We know less than is subtraction, and it's a turnaround phrase. So we're subtracting 8. The product of a number and 3, we don't know what that number is. That's our variable. And is, that's equals 22. So this is our equation here. And then to solve it, add 8 on both sides of the equation. I have 3x equals 30. Divide both sides by 3, and I get x equals 10. All right, when I check my answer, I have 3 times 10 minus 8 equals 22. So that's 30 minus 8 equals 22, which is correct. So part B is x equals 10. All right, number 11. 6 more than 20 times a number is 206. So that's going to be 20 times a number. 6 more than that equals 206. So this is part A, my equation. All right, then to solve, subtract 6 on both sides. We have 20x equals 200. Divide both sides by 20, and we get x equals 10. All right, then we'll check it by substituting our answer back into the original equation. All right, so 200 plus 6 equals 206. That's correct. So I know that x equals 10 is correct for part B. All right, problem number 12. Okay, it's asking for the equation and the solution to the problem. So it says, Abby and Ben ride their bikes each day for exercise. Ben rides 2 miles more than Abby each day. If together they ride 9 miles, how many miles does Ben ride each day? So as with many problems, there's multiple ways you could solve this. One way that I bet a lot of you are going to do is working backwards from the answer choices, which is always a smart method to use. And if you use that method, you should be able to eliminate A right off the bat, because it tells us that Ben rides 2 miles more than Abby. So if he rides more than she does, and he only goes 3.5 miles, then there's no way together they could have a total of 9 miles. So right off the bat, we know that that doesn't make sense because of the solution for Ben. All right, now, another thing I want you to pay attention to is some of the keywords in the problem. If he rides 2 miles more than Abby, 2 miles more, that would be adding 2. Okay, and so if I look at C, There's nothing here that involves adding 2. Part B doesn't involve adding 2. D does. All right, so let's explore what this is showing us. So if Ben rides 2 miles more than Abby, let's say Abby rides X miles a day. Okay, if Ben rides 2 miles more than she does, if she rides X and he goes 2 more, his distance would be represented with X plus 2. So in all, X plus X plus 2 equals 9. Okay, so that's where this equation comes from. And then to solve the equation, just to make sure that this answer here is correct, this is the same thing as having 2x plus 2 equals 9. Okay, and then I'd subtract 2 on both sides. I have 2x equals 7. Divide both sides by 2, and I get x equals 3.5. Well, you might be saying, wait a minute, that's 3.5. The answer here is 5.5. Notice that that's what x equals. Okay, x represents Abby's distance. It's asking how far Ben went. So if Abby rides 3.5 miles, he goes 2 miles more than that, which would be 5.5 miles. And if you go back and check, 5.5 plus 3.5 does equal 9. So it makes sense within the context of the problem. So number 12, our answer should be D. All right, let's flip to the last page. So let's take a look at problem number 13. James has spent $20 of his $35 video store gift card. He plans on using the remaining balance to rent video games. If the games cost $2.50 each to rent, how many games can he rent? Write an equation and solve. Well, the video store gift card was a total of $35. So we know that that is on one side of the equation. All right, now that $35, that $20 that he already spent was part of it, okay? And the other part of that $35 is the video games that he's going to rent. Those video games are $2.50 each, so that would be $2.50 times X, which represents the number of video games, plus 20 equals 35. Okay, so again, this is the total balance of the gift card, and that was made up by the $20 that he already spent and $2.50 per game. So that's where this equation comes from. Now we need to solve for X. So subtract 20 on both sides of the equation. We're left with $2.50 times X equals 15. Divide both sides by 250. And we get X equals, and just a reminder in case we've forgotten how to divide by decimals, yes, you can use a calculator, but this is a skill we need to know. So here's how you would do it. 15 divided by 250. I'm just going to write that without the decimal because I don't need that there while I'm dividing. All right, my divisor has to be a whole number, so move that decimal over once. Then I have to do the same thing here and fill that in with a 0. So now my problem is 150 divided by 25. And 25 goes into 150, like think of quarters. That goes in 6 times. So I have X equals 6. Okay, and let's go back and check it and see if that makes sense. So video games are $2.50 each, and he buys 6 of them. Plus 20 that he already spent equals 35 on the gift card. All right, so if he rents 6 video games at $2.50 a piece, 6 times $2.50 is $15. Plus 20 equals 35. That's correct. So I know that this answer is right. All right, so on number 13, this is our equation, and this is our solution. Okay, all right, let's look at number 14. Okay, so we are solving the inequality and then choosing the graph that goes along with it. Okay, and you've got to be careful on this one because I know every year this is one that a lot of people tend to miss. So please be careful with this. So my first step is I'm going to subtract 3 on both sides. Subtract 3. That gives me negative 2x is less than, and this is 18. All right, now divide both sides by negative 2, and I have x. And then 18 divided by negative 2 is negative 9. And be careful, we just divided both sides by a negative, so we reverse the inequality symbol. So that becomes x is greater than negative 9. So when you look at your options on the page for your graph, if our solution set is x is, let's see, greater than negative 9, well, it's obviously not C or D, okay? So it has to be either A or B. Well, they are both open circles on negative 9, and since it's greater, we're shading to the right. So our answer should be B. All right, take a look at problem number 15. Stephen owns a bicycle rental stand at the beach. He uses the equation C equals 350H plus 5 to determine C, how much he will charge to rent a bicycle for H hours. Which of the following is a reasonable amount someone would pay to rent a bicycle from morning to evening on one day? So the total cost is $5 plus $3.50 per hour. Okay, so we're trying to figure out what is a reasonable amount somebody would pay for the entire day. Well, right off the bat, I see that there's two answers that do not make any sense. Okay, if this is our equation here, there's no way somebody is only going to pay $3.50 because they have to definitely pay at least $5. So A doesn't make sense. B also doesn't make sense that they would only pay $5 because it's $5 plus $3.50 per hour. So that's basically renting for 0 hours, which makes no sense. So B can also be eliminated. All right, so now we have $15.50 or $47. Okay, so with this one, again, this is one where you can kind of just use logic to figure this out. It says from morning to evening, so that's going to be several hours. So if you're renting for several hours, the only one that really makes sense here is D. All right, now I could also solve, okay, using both of these values just to see what would make sense. And to do that, what I would do is I would substitute this amount here for C. Okay, so for instance, on C, I would have $15.50 equals $3.50 H plus 5. So again, I'm just substituting the answer in place of C, and then I would solve for H. Well, in this case, H would equal 3. And then I could do the same thing over here, plug in 47 for C and solve for H, which is the number of hours. Okay, when I solve that one, I get H equals 12. So this amount would be true if it's 3 hours of rental. This one is true if it's 12 hours of rental. So if it's from morning to evening, that's more likely to be 12 hours. 3 is not long enough. Okay? All right, problem number 16. Okay, so a rectangle has 4 equivalent angles. Okay, we know on a rectangle, all the angles are going to be 90 degrees. So we're trying to figure out what the value of X is right here. Well, again, we know that this entire amount has to equal 90. Okay, so my equation is 5 times X plus 13 equals 90. And then we're just solving for X. I could apply the distributive property first and then solve, or I could say, okay, 5 is farthest from the variable since the 13 is inside the parentheses. So since that's being multiplied, I'm going to divide both sides by 5. That gives me X plus 13 equals, and then 90 divided by 5 is 18. Subtract 13 on both sides, and we get X equals 5. Okay, if we check it, we'll plug it back in. So I have 5 times 5 plus 13 equals 90. That's 5 times 18 equals 90, and 5 times 18 is 90. So I know X equals 5. All right, problem number 17, okay? Okay, so on this problem, Elijah's saving for a summer vacation in Florida that costs $550. He has $250 saved and hopes to lifeguard at $20 per hour to earn the rest of the money. Which inequality below describes the number of hours he must lifeguard to have enough money for the trip? All right, so our total is $550. So we can see on all of these, $550 is by itself on one side of the inequality. All right, and then he already has $250, and then he's also going to lifeguard at $20 per hour. So if it's $20 per hour, we'd represent that with 20 times H, okay? So I know I can eliminate C because that doesn't make sense. That's not showing us $20 per hour, okay? All the other inequalities do show that, okay? Now I also can eliminate D because D doesn't even include the $250 that he already has saved. All right, so that does not make sense either. So that leaves us with either $250 plus 20H is less than or equal to, or $250 plus 20H is greater than or equal to. All right, so he has $250 already, plus $20 per hour, okay? So think about if he's trying to save enough money in order to go on the trip, would he need to make less than or equal to $550 or greater than or equal to 550. Well, think about it. If he made less than 550, is he going to be able to go? And the answer is no. He needs to have at least 550. So that would be greater than or equal to. So our answer here is B. All right, problem number 18. Which property is demonstrated in the equation? If you notice, the values in the parentheses didn't change. The only thing that changed was the order. Okay, so when we reverse or change up the order when we're multiplying or adding, that's the commutative property. Now, if the values in the parentheses had changed, then it would have been the associative property. Okay, last problem. Which expression is not equivalent to negative 8x minus 24? Well, the first thing I would actually do on that is rewrite that as negative 8x plus negative 24. Yes, they mean the exact same thing, but as I've said before, it's going to be easiest to write your minus signs as adding the opposite. So we're going to, I guess, simplify each of these answers here to see which one does not equal this value. Okay, so for A, when I combine my like terms, negative 10x plus 2x is negative 8x, and then 10 plus negative 34 gives us negative 24. So that one does equal the original value. All right, for B, I'm going to change the minus to adding the opposite, and then distribute the 4. 4 times negative 2x is negative 8x. Keep the plus, and 4 times negative 6 is negative 24. So that also gives us the same value. All right, C, okay, I have negative 8 times x is negative 8x, plus, and negative 8 times 3 is negative 24. All right, don't just assume the answer is going to be D. Go ahead and work that out as well. So I'm going to change this to adding negative 3. Then I'm going to distribute, and that's negative 8x plus, and then notice we have negative 8 times negative 3. Well, that's a positive 24. So this is negative 8x plus 24. That's negative 8x plus negative 24. So the one that did not equal that value was D. Okay? Okay, so I'm going to go ahead and show you the answers one more time so you can check your answers. You may need to pause. Okay, that's page 12. Then we have page 13. And then the last page, page 14. All right, guys, hopefully that helps. And let me know if you guys have any questions. Bye.